This is the 4.4 and 4.7 review. Calculators are not allowed, and the problem is number 2, where we are again going to be dealing with indeterminate forms of limits. Now with each of these, when we plug in infinity, we will get a large number on top and a large number on the bottom. Same thing here and here. Same thing here and here. So in all three of these, we have an infinity over infinity sort of indeterminate form. That means it's a candidate for L'Hopital's. But if you remember from Chapter 2, we have two different ways that we can now deal with limits as we approach infinity. The first is second one we learned was L'Hopital's rule. And if you look at my online review solutions, I've gone through every single one of these using L'Hopital's rule repeatedly. However, I personally think it is quicker to do these processes like we did in Chapter 2 when we were looking for horizontal asymptotes. And in that scenario, what we looked for were the dominant terms. And so I'm going to do each of these using dominant terms so that you have access to both options. You can either do L'Hopital's repeatedly, or you can do your dominant terms. So if we look at this one, we can see that the 2x will dominate over the 3, and then the x root x is the only term on the bottom. So that expression that I have written in Part A is equivalent to this expression, which I can now reduce. X will cancel with x. I'll get a 2 over root x. And the limit of that as x gets gigantic is going to be 2 divided by a really big number, which gets closer and closer to 0. So no L'Hopital's were required. We were still able to compute the limit. Same thing with Part B. If I again identify my dominant term on top, which is the 3x to the 4th, and the dominant term on the bottom, which is a 5x to the 4th, then the x to the 4th can cancel, and I can just get a 3/5. I would arrive at that same answer using L'Hopital's, but I would have to take multiple derivatives, I think 4 of them, before I would end up getting to this term. So in this case, doing the dominant terms is significantly more efficient. Last one, Part C. I'm going to rewrite an interior power as an exterior coefficient. And when I do that, then one of those log natural of x's can cancel, which means I'll have a 2 on top and an ln of x on the bottom. Well, again, I have a number divided by something that is getting progressively larger and larger, so that limit is going to be 0.